Okay. Last time we were discussing electromagnetic waves. Electromagnetic waves, the longest wavelength belongs to radio waves, and the shortest wavelength, the highest frequency and highest penetration ability goes to gamma radiation. Today's topic will be all about visible light. That is exactly the mid part of electromagnetic spectrum. The smallest frequency, the smallest energy that is visible to human eye is red. For example, if you start heating up a piece of steel, the steel can start like it will be getting warmer and then hot and very hot and very hot, and there will be a time when it will start to become visibly hot. What is the first visible color that the iron will take when it will become very hot? Answer is red. The first visible color when something becomes very hot is red, and then it becomes more hot. Iron starts to turn orange, and when it it starts to get to the yellow color, it melts. That is the maximum iron can take. So this will this will help you to remember the energy distribution over there between the colors. The first visible color is red. So the least energy that human eye can see or a human eye can understand is red. Any energy which is less than that is called infrared. Infra means less, inferior. Infra means this word is coming from inferior. Inferior means less, small, diminished. So something which will have energy less than red color will be known as infrared. And the first visible color is the first first visible energy level is red, orange, yellow, green, and in this order the energy is increasing: blue, indigo, violet. Violet is the maximum human eye can see. If energy is increasing from red to violet, you can clearly see the wavelength is decreasing. The longest wavelength human eye can see is red. Longest wavelength highest frequency. So down the order from red, orange, yellow, green, blue, frequency increases and wavelength decreases. Red is the longest wavelength human eye can see, and violet is the shortest wavelength human eye can see. Now, this is the order of wavelength. You don't need to remember any of them. Actually, you don't even need to remember that the smallest wavelength is 400 and largest wavelength is 700. But this will help you to answer any question anyway. But this is not the requirement of the syllabus. But you need to remember that there is a smallest wavelength, there is a largest wavelength, and there is the smallest wavelength will belong to violet, and the largest wavelength will belong to red. And these are the properties of all the colors. Okay. Now, just 1 second. Okay. Now, here are the properties of light. Number one, light is emitted radially outward from the source, because light comes out in form of particles as photons, and those photons they come out of the source in straight lines, and they travel away from the source, and they travel away with the speed of 3 into 10 to the power 8 meters per second. So light is emitted radially outward from the source. Light travels in straight line within a single medium. Light reflects from the shiny surfaces. Light gets absorbed by the dull black surfaces. Light refracts when it goes from one medium to another medium. Light disperses when it passes through a triangular prism. So these are the properties of light. And because light is particle in nature as well, along with waves. So if somebody asks you what is the light particle, you can say it is photon. Photon means light. Photon means the particle of light. Light is wave as well as particle in nature. Dual nature of light. So light is wave as well as particle. Now, reflection of light. When light hits this shiny surface, surface that light cannot penetrate, light cannot get absorbed, light cannot pass through, the light has to bounce back. This phenomenon is called reflection of light. The same kind of thing was studied when we were studying reflection of waves. It is exactly the same thing. In this case, the wave is light. That's it. All the properties are same, all the phenomena are same, all the laws are same. Reflection of light means when light hits a shiny surface, the surface that light cannot pass through or get absorbed in, it bounces back. This bounce back of light is called reflection of light. Law of reflection of light. Ray of incident and ray of normal must be, and ray of reflection, they all must be in the same plane. Number two, angle of incidence is equal to angle of reflection. So whatever the angle wave makes with the normal, it reflects with the same angle as well. So angle I and angle R in the diagram are equal. And one very basic thing, all the angles are always measured from the normal. Okay, we don't measure angles from the surface. We always measure angle from normal. Now, image formation in mirror. Excuse me. Image formation in plane mirror. Note image in plane mirror, like these are the properties of image. When we see something in a mirror, and I'm talking about plane mirror. Some mirrors are curved mirrors. For example, the side mirrors on your car, they are concave mirrors. Actually, no, so convex mirrors, and their job is to increase the field of the vision, but they reduce the size of the object. Similarly, there are mirrors, beauty mirrors that are used for makeup like if you need more details in your image. So what they do is they increase the size of the image. Such mirrors are called those are magnifying mirrors, or they're called beauty mirrors. So these mirrors are supposed to increase the size of the object. But we over here are discussing plane mirrors, straight, plane surface. It is neither curved outward nor curved inwards. In that case, the image that plane mirror forms has these properties. Number one, same size as object. Image is same size as object, same distance in the mirror as the object is from the mirror. Upright, like if you're standing in front of a mirror, your foot will be in front of foot and your head will be in front of head. It is not like you're upside down in your plane mirror image. So that means upright. Image is laterally inverted. If you're scratching your head with your right hand, your image will be scratching its head with the left hand. Okay, and if you try to shake hand with your image with your right hand, your image will extend its left hand. So that's why the shake hand can never take place, because it is not done with the right hand. So that kind of situation is known as laterally inverted. The right looks like left, and left looks like right. Image is virtual. Virtual image means what? This is a term used over here, and this is where it has been explained. Image can be real or virtual. Virtual means an image that we can see but cannot produce on a screen. So these kind of image is always required the position of eye to show the position of the image, because the image will change because of the position of the viewer or eye. So virtual images, they depend on the point of view. Number two, virtual images, they cannot be produced on a screen. Let's see what are real images. Real images are those images that we can produce on screen. For example, image of a projector. Okay, because we can project it on a uh, surface. And those images will be, excuse me, those images will be same no matter where you look at them. Okay, so they do not depend on your point of view. They will always be same from anywhere, mm, in the field of the vision. So they don't depend on point of view. So for real images, you don't need to draw the position of eye. But for virtual image, you need to draw the position of eye. For example, look over here. There is this object O, which is placed in front of the plane mirror. So I knew, because this object is 2.5 box away from the mirror. So the image will be 2.5 box inside the mirror. Then the light rays are hitting the uh, plane mirror and then reflecting towards the eye. So I will conceive an image in front of the light rays that the eyes are receiving. So image will be formed at position I. Okay. So in plane mirror, image has the same size as object. Image is laterally inverted. And I hope you have seen these kind of this is my drawing, so I did not make the effort that I could have made. Yeah. So this is an ambulance, and um, ambulance has all the letters written inverted. Can you think of any reason why? Why do we have all the letters printed on an ambulance inverted? Answer is, so when somebody sees an ambulance in a back mirror, for example, there's a car, a person driving a car, so he sees an ambulance in his side mirror or center mirror. He will be looking at an image which will be laterally inverted. So ambulance is written inverted. So when it will be inverted again, that person will be looking at the right image. For example, if you take this image, save it, and then for example, take a screenshot of this image, and then point your screen towards a mirror, and in the mirror you will find out it is the ambulance will be the way it should be. Okay, just 1 second. Okay, I'm back. Now, if you look at these images, they look inverted, and when you see them in mirror, they will be inverted again. And if you invert something twice, you find them the right way they should be. So these are some diagrams to show you that images, as you see them in mirror, they are same distance as the object is from the mirror, and they are laterally inverted. Hold on a second. Okay, so that is enough for refraction. We'll be doing some past paper questions, and then it will be better. Now, refraction of light. Well, light very much like refraction of waves. When waves go from one kind of medium to another kind of medium, when the speed changes, they are not parallel to the normal. They're entering a different medium at an angle. Then they cannot keep their course. They are supposed to bend from their original path. Such bending of a wave is called refraction of wave. And if the wave is light, then it will be refraction of light. Now, light bends when it goes from one kind of medium to another kind of medium. First of all, you need to understand that light can travel either through vacuum, or it can travel through transparent media. When light goes through transparent medium, it depends on the nature of that material or nature of that medium. This is called optical density. Some materials have very high optical density, so the light travels slowest among them. Some materials have low optical density. Light is fastest in them. For example, vacuum. Vacuum is where the light is fastest. It is comparatively slower in air, but for your syllabus, you will not be considering that difference because that difference is so small that we can ignore it. When light goes from vacuum to air, the speed is almost same. So for your syllabus, if somebody asks you what is speed of light in air, 10 to 10 to the power 8 meters per second. What is speed of light in vacuum? 10 to 10 to the power 8 meters per second. So speed of light will be same in air and in vacuum. When light will go from air to water, it will get slowed down. Just one bit. Okay, I'm back again. Now, water is optically denser than air. Then ice is denser than water. Glass is denser than ice, and then diamond is 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 where the which has the highest optical density and slowest speed of light. So you can clearly see over there that speed of light has become 1.2 into 10 to the power 8 meters per second. Do you need to remember them? Answer is no. Do not try to remember them. But if you do, that is good. But it is not a requirement. The only speed that you need to remember is the speed of light in air, 3 into 10 to the power 8 meters per second. This is where examiner can straightforward ask you this question without any reason, without giving you any data. What is speed of light in air? What is speed of radio waves in air? What is speed of gamma radiation in air? What is speed of light in vacuum? What is speed of light in light? What is speed of infrared light in vacuum? For all those questions, answer is 3.0 into 10 to the power 8 meters per second. All of these waves travel with the same speed in air and in vacuum. Oh, but um, you don't need to remember other speeds over there. Like what is speed of light in glass or what is speed of light in diamond. That is just for extra information. Let me put star over there. Okay. This means you don't need to remember them. Look away. Light is coming from air, it goes into glass, and in glass, it is supposed to be slowed down. When light slows down, it bends nearer to the normal. And again, if you remember what happened in waves, it will make your job easy to understand refraction of light over here. When wave going from one medium to another medium, if uh, wavelength decreases, speed decreases. Speed decreases, angle from the normal decreases. So all these three things, they are synchronized with one another. They are directly proportional to one another because they all change in the same ratio. When light goes from optically less dense medium to more dense medium, it is supposed to slow down. When speed decreases, wavelength should also decrease. And when wavelength decreases, angle from the normal also decreases. So when wave becomes slow down, it bends towards the normal. And when wave speeds up, in this case, I'm talking about light wave. When light wave speeds up, it bends away from the normal. Okay. So refraction of light is bending of light when it goes from one medium to another medium. When light goes in a medium where it's supposed to slow down, it will bend towards the normal, and bending towards the normal means getting closer to the normal. Okay. So when light goes from less dense to more dense medium, light slows down, wavelength decreases, light bends towards the normal, no effect on frequency. So frequency is totally unchanged. Frequency will not change, it will stay the same. Okay. And the opposite happens when light goes from uh, denser medium to less denser medium. See, this is the kind of situation where light goes from glass into air. So when light goes out of glass into air, it bends away from the normal, speeds up, wavelength increases. Now, law of refraction, zeroth law. This is just my term because it is one very basic information because all of the angles are measured from the normal. Angles are never measured from the surface. Yes, we can measure the angle, but those angles will not be recognized as angle of incidence or angle of refraction. Angles from the surfaces are not very authentic. Okay? So all angles are always measured from normal. Number two, ray of incidence, ray of refraction, and normal ray, they must be in the same plane. Because we are talking about three-dimensional, like there can be a situation of light going from like moving in three-dimensional space as it normally does. Then there will be a problem because it will be difficult to measure the angles. So for the simplicity, we are considering that all of the light rays are in same plane. Second is that angle of incidence is directly proportional to angle of refraction. So if you increase the angle of incidence, angle of refraction will also increase. So sine I is directly proportional to sine R. This is it, the relationship known as Snell's law. So it will be sine I over sine R. Be very careful over here. If this is the situation, yes, it will be sine I over sine R. But if this is the situation, then it will be opposite. It will be sine R over sine I. How would we know? How would we know? Answer is it is always sine of bigger angle divided by sine of smaller angle. See, it is always sine of bigger angle divided by sine of smaller angle. This ratio is known as refractive index. Sin I over sin R is known as refractive index. So n equals to sine of angle in air divided by sine of angle in the medium. So it is always sine, because remember, for your syllabus, refractive index will always be more than 1. So if it is more than 1, it has to have a bigger numerator than denominator. Now, refractive index can be measured with all these all these formulas. Number 1, refractive index is sine of angle in air divided by sine of angle in medium. Refractive index is speed of light in air divided by speed of light in medium. Refractive index is wavelength of light in air divided by wavelength of light in medium. They all will get you the same answer. So that also allows you to put them equal to one another. For example, I can do sine I over sine R equals to real depth over apparent depth, because they all are refractive indexes in index. So I can put them equal to one another. Okay, I think that rest of the things are easy over here. Note down these formulas because they are important. We'll resume from same point tomorrow. We have to do critical angle, total internal reflection, and come to lenses so we can complete the chapter. Okay.
Okay, sir. Allah Hafiz.
Okay, sir. Lots.
Allah.